Okay, it's just a couple minutes after 10 o'clock, so we're going to get started this morning, or on the next session, 10 o'clock, RCP Basics. Really excited by the attendance here. I know we've got a mix of designers and consultants and contractors, so I'm hoping that we're going to tell you some things that we think are going on in the concrete pipe industry, and we're hoping that we have some open discussion around what we say and what you guys want to say, and hopefully you'll ask questions and really encourage you to participate. That's why we're all here. Really, the important part of this session, I will also mention that the session we're offering right now is completely different from the session that we're offering this afternoon. So both are based on concrete pipe, but this afternoon is on post-video inspection and evaluation. This morning is on design and installation. So two entirely different topics, so hopefully you guys will all find time to join us at both sessions. Al Hogan is here. I'm going to introduce him right now. He's works for the American Concrete Pipe Association, is the spokesperson for all the concrete pipe industry and all matters affecting its welfare. ACPA members contribute to the improvement of the environment by producing quality concrete pipe engineered to provide a lasting and economical solution. There are currently over 400 plants operated by ACPA members in the United States and Canada, and over 40 countries are represented. Al is the Eastern Regional Engineer for the American Concrete Pipe Association. He's a Bachelor of Science Civil Engineering from the Tennessee Tech University. He's registered as civil engineer in the state of Tennessee. He's got a number of years' experience with the construction division of the Federal Highway Administration, and Sherman-Dixie Concrete Industries, who's a manufacturer of concrete products, so he can speak from both the design side and the production side. And he's also a former board of director and technical committee chairman for the ACPA. So we're really proud and happy to have Al here this morning. I think we'll all be enlightened, and hopefully we can have some discussion on what he has to say.
Thanks, Rylan. It's great to be here. I want to thank Rylan and Shaw for inviting us to come up. I don't get a chance to come to Canada very often, maybe a handful of times a year, so this has been a nice trip for me. I've never been in Nova Scotia, my first trip here. I'm from a little town, and let me tell you what they're famous for, and then I'll get on with the presentation. I'm from a little town called Columbia, Tennessee. Anybody ever been to Columbia, Tennessee? Oh, no cheering in the crowd. I kind of figured that would happen. Our claim to fame is we are the mule capital of the world. No kidding. Now, how would you like to be from the jackass guys? Anyway, so hopefully I won't live up to our name there, my hometown. But anyway, it's a kind of cool thing. And by the way, this weekend's Mule Day, so if you don't have anything to do this weekend, fly on down to Columbia, Tennessee. We'd love to see you. Anyway, it's great to be here. And I think we have a couple good topics to talk about. As Rylan said, it would be awesome if you guys would ask a few questions, interact a little bit. That will help things. I know it's a big crowd, and folks are a little scared sometimes to ask questions in front of folks, so please don't do that. Jump in there and ask a question. It'll make things go better, and I'd appreciate it, and we'll have a lot more fun if we discuss some things. So let me get started. As Rodney said, we've got a couple of topics to talk about today. The first one, we're going to cover mainly two topics, the design of concrete pipe, as well as the proper installation techniques and those kind of things. I think those two things tie together very closely, and we'll talk about that as we go through the presentation. I am going to give you the Reader's Digest version of those. There are a lot of things we could talk about. I'm going to try to stress the things that I think would be important to you, both from the installation and design processes. If we really cover both those topics very thoroughly and very technically, which would put you to sleep for one thing, another thing, it would take probably a half a day to do that. So you get the Reader's Digest version, but we have some really good tools available to you at ACPA resources. I scattered some of those throughout the crowd. The folks who were here early got a copy, and there's some scattered around. So as we go through, kind of be watching for that little crescent wrench symbol there, because those are tools that we have available that speak more to the topics or the specific thing that we're talking about on the slide that may be helpful to you if you want to read more, learn more, those kind of things. If you want some of those tools, if you didn't get any in your chair today, come see me at our booth later on. Give me a card. I'll take care of you. Or you can go on our website and get those as well. They're all available there. All right, first question. You got to answer this question. Somebody does. What does a buried pipe, what's the function of a buried stormwater pipe? What's the two main functions? I see a lot of hands going up. Come on now. I heard the first one, convey water, be a conduit. All right, that's awesome. We got one down. I like that. Be there in 3 or 4 years. That'd be nice. We hope it's there a lot longer than that, but yes, got to last. I'm looking for one other thing, though. It's got to be a structure. There we go. Thank you. You know, really, pipes are underground bridges. That's really what they are. And when we're talking about design of piping products, no matter what kind of piping product you're talking about, usually engineers. How many engineers I got in the room? How many consulting engineers? Holy cow. I'm in trouble. You guys are smarter than I am. No. Anyway, what do you think about? What's the first thing that comes to your mind when you think about designing a piping system? What's the first thing that comes to your mind? What do you think about? Capacity. Thank you. You think about hydraulic capacity. That's always, I was in design for about 12 or 13 years. Did general civil site design. When I had to think about designing storm systems, first thing that came to mind. Even a more, or at least as important concept for us to get a hold of is the structural capabilities of the pipe system as well. So we'll hit on that quite a bit today. No matter what kind of piping system you use or what type of pipe you want to use, they all, in some form or fashion, the structural system is a combination of both the pipe and the soil around the pipe. So all the pipes are a soil-pipe interaction to create the structure. Now, two or three things that makes, boy, this thing's loud. Two or three things that makes reinforced concrete pipe unique. First thing is, on the truck, we bring you a conduit, and we also bring you a civil engineered structure. We'll talk about the civil engineered structure a lot as we go through this. That makes us a little different from other products, I think. Another thing that is unique about concrete pipe, as the pipe diameter gets larger, our product has to be constructed and manufactured to meet a greater load. Makes sense? Wider trench, more dirt over the pipe, need to be a stronger pipe as it gets larger. That is a unique thing about concrete pipe, and that is also taken into account as we do our design methodologies. The other thing, we're one of the only pipes that is manufactured that truly has a structural design of our product before it leaves the plant production facility. I'll offer this to you, and I'm sure this is okay with Shaw, and I assume most of you guys are fairly local here. It would be a great thing for you to go see pipe manufactured. Do a plant tour, what we call a plant tour. Awesome thing to see. Two things that are really important that I want to make sure if you ever get a chance to do that, you pay attention to. One, good materials, or several things. Good materials, good quality control, how fast a product is made, and it stands on its own very quickly. That's done because we use a very dry concrete mix, very strong mix. That's kind of a cool thing. Most people wouldn't think that a pipe, as soon as it's produced, stands on its own with no support. The other thing to watch is watch one of these structural confirmation tests that we have to do on our product. Here's a good example of it. On our product, we have certain criteria that we have to meet as far as strength, and we'll talk about that in a few minutes, different class strengths. But this one, typical class 3, pretty plain vanilla type design, 60-inch pipe, we have to actually exert 54,000 pounds of load on that pipe in a test rack that looks like this, called a 3B test rack, and it cannot crack under that 54,000 pounds of load with no support around the pipe. We also, to prove we have ultimate design strength, we can actually go on and test up to 80,000 pounds, and that pipe will still continue to take load, even at 80,000 pounds. I'll just say, well, gee whiz, what does all that mean? 80,000 pounds, that's not metric. You're thinking, I wish you were talking my language. I'm sorry. I'm not so good at that. But I'll show you a picture that'll make sense. Tractor trailer, loaded with concrete pipe. If we could pick it up by crane, by the back end, and set it on a 60-inch pipe on its bumper only, sitting out in our yard, and let the truck go, and it perfectly balanced on its bumper on that 60-inch pipe, that pipe could not fail. So that is the severity of the strength test that has to be done. So those are some unique things about concrete pipe. And the only reason I bring those up is if you are using other piping products, there's nothing totally wrong with that, but you have to understand how they work. You have to understand the design. The design is different. Their soil structure interaction is different. and you have to accommodate those in your designs and your standards. So it is important to understand those, and if you are working with different piping products, you need to hear some of these things like we're talking about today for our products as far as structural design. You need to understand how to do that with other products as well. Now, let's talk about concrete pipe design for a minute. Again, I'm not going to get way off in the technical side of this and do a lot of calculations because I know that will, like, lights out, put you to sleep. I've done that before, and it happens to me every time. When I start doing calculations, I go, what do you say? So we won't do a lot of calculations. We will keep the design pretty simple, but I do want you to understand some of the very important concepts that you've got to do, no matter what type of design you want to do as far as tools you want to use that we have available to you. Again, we're going to concentrate on the structural side here for a few minutes on the design of concrete pipe. There's a couple methods. The most commonly used design method for concrete pipe is the indirect design method. That's what we'll be concentrating on today. That is the most commonly used. We've used it now since the early 1900s. We know it's proven. We know it works. It's easier for our manufacturers. It's easier for designers to use, I think. The concepts are pretty easy to grab a hold of. And so that's the reason most people use it. It's a little bit quicker than using another design method. When we mean indirect design, basically what we have to do is we're coming up with a load, soil load and live load on the pipe. We're converting that load into pounds per foot of diameter per foot of pipe. If you remember the calculation just before that, that's what we did. We took a certain required force on the pipe times the length of the pipe times the diameter of the pipe to come up with the total load that we have to place on that pipe. So if we know that load and can convert our in-the-field load that we expect to see, if we can convert that load into pounds per foot of diameter that we have to test in our test rack, then if we know that, we know a class of pipe, a strength class of pipe. We make strength class of pipe from class 2 up to class 5. Here it's D65 to D140. That would be class 3, 4, and 5, correct? Isn't that what it would cover? So we make different strength class of pipes. So if we know what that load is and we can convert that to our test rack load, then we know what class of pipe we need to have, whether it be a class 3, class 4, class 5. If we know that class of pipe, we can then go to the standards, and we have a recipe to go by. It tells us how much steel to use in the pipe. It tells us how much concrete strength we need to do to develop in our product. And we know what our test load is. We already talked about that to confirm that we built it properly. So we're given, I guess you might call the indirect design a load, and then you take that load and apply a recipe to it to build the cake, the pie, to make sure that you're providing the right structure, and we tested to make sure we got it. So we got a load, and we have a recipe to go by to build that product. That is, in a very short form, what indirect design does, indirect design method. So your deliverables there, load, class of pipe, steel area, concrete strength, those kind of things. So we got a load and a recipe. The other design method would come into play, and it's called the direct design method. Let's say, for instance, you have a load, you calculate a load that's more than 100, what's the highest load, 140? Let's say your load that you calculate is more than 140D, or for me, it's more than 3,000 pounds per foot of diameter, which would be a class 5. That's the comparison there. So we have a load that's more than that. Well, I can't use indirect because I don't have a recipe, right? I have no recipe for anything greater than that. If you look at the standards, that's as far as the recipe tells me. So I'd have to use some other design method. Now, when that comes to play, usually is your very deep installation, large diameter. Deep installation would create a lot of dead load in the pipe. Or you have a very severe live load. One of those two situations could create a load that would not fall within my recipe loading for indirect design. So you'd have to use direct design in those cases. Now, what direct design does, it's more of a structural analysis. You calculate your load just like you would for indirect design, but then you apply that load through the direct design process to look at shear, radial tension, crack control, like you would do any other structural design of a concrete beam, bridge structure, any of those kind of things. So it's more of a full-blown analysis. Given a deload, then you put that deload into, we have software package now, thank goodness. Put that deload in. You can change steel areas, you can change concrete strength until you figure out one that will work and would not cause a problem with flexure or crack, those kind of things. So it's a more classical structural design, you might say. But now with that comes a little more time and those kind of things. You do get some deliverables out of that, obviously. Basically what you do in direct design, you're going to write the recipe. You as the designer or you as a municipality engineer are going to write the recipe for Shaw to build to. So you're going to now tell them what the recipe is. You're going to tell them, we have a D-load, and here's my steel I need for that. Here's my concrete strength you need for that. Here's your wall thickness you need for that. And then you may even say, we want you to test it as well to make sure it works. There are times when the designer will give a D-load. So we know our D-load is 150 D in this case. You've done that much work. And then Shaw or other bidders would have to provide you a design. If they do that, they would use direct design. Okay? So there are times to use it. Now, again, the most common method is indirect design. Let's spend some time there. There's several tools that are very helpful to you. The Blue Book, this is the Concrete Pipe Bible, I guess you might call it. It's the Concrete Pipe Design Manual. These are available in hard copy for us old guys, and they even have a CD now for you young folks that like to use the computer. And I'm sure within a few days we'll have an app for your iPhone. We hadn't got there yet, so I'm sure that's coming. But those are available to you. They've been around a long time. Very, very good document. We'll take you through, if you want to do that and learn more about indirect design, really run through a full-blown calculation of indirect design by hand. You can use that Blue Book. We have about 10 or 12 examples, different live loads, different depths, different shapes, all those kind of things. Almost any normal example that you would be faced with, different live loads, railroad loads, aircraft loads, tractor-trailer loads, no loads. So there's an example in there that would be probably easier for you to change a few numbers out based on your particular instance and run through hand calculations. I would suggest if you haven't done much concrete pipe design, you use the Blue Book first. You run through a couple hand calculations to understand where all the numbers come from. I'm going to give you a shortcut here in just a minute so you don't have to do that. But for folks that haven't done concrete pipe design, I would suggest you do that first to make sure you understand the concepts, because we won't be able to get into all of the technical jargon today and the issues that you need to be fully aware of when you do even indirect design to calculate those loads. So going through the Blue Book would be helpful. The other design tool that's very helpful, and a few of you have these sitting in your chair, so I'll let you go ahead and grab one because we're going to be talking about this for a few minutes, are fill height tables. All right? So we'll talk about those in a minute. That is a tool to do an indirect design. And we'll talk about how to use that properly and safely in a few minutes. We also have a software package called Pipe Pack, or software program, and inside of that package there is a 3B module. So that's your indirect design module in that. Pretty self-explanatory. A few blanks to fill out in there. It'll pop out the design for you. But again, I think it's nice to know the Blue Book and see if that makes sense when you get the answer. But it's a very good tool, very easy to use. Get some good help screens with the Pipe Pack. That can be available to you. We'll talk about when you could use that as well. But again, we're going to concentrate on fill height table today for sake of time. We want you to have enough knowledge to be safe. And again, we've got some good tools. You can read more about it if I don't cover everything thoroughly enough today for you to understand it. In the indirect design process, these 7 steps, you have to go through these 7 steps to determine your load. That's the biggest thing. You know, in indirect design, we're just trying to come up with a D-load, a design load. That's all we're trying to come up with, basically. There's 7 steps to do that. No matter what tool we use, whether it be the fill height table, the Blue Book, or the computer software package, these 7 steps have to be done. Now, for the fill height table, obviously, you can't flip a page and do 7 steps. I mean, that's not going to happen. But behind the scenes, these 7 steps have been done for you. Some of them have. So, any indirect design, these are the processes you have to go through. You have to determine the pipe installation method. We'll talk about that a good deal in a minute. You are calculating dead load, which would be your soil load and your fluid load inside the pipe. We're going to have to calculate live load. We're going to have to select a bedding type. And we're going to have to determine from that, we can find a bedding factor. Apply a factor of safety. 1.5 is the normal factor of safety we apply to all our designs. And then from that, we convert that into a D-load, pounds per foot of diameter, and then we'll know what class of pipe we need to use. Okay? So all those steps have to be used in all the different tools we're going to hand you. Now, Important concept here in any one of the tools you use is your pipe installation method. It's very important. Which one of these methods is the most common method used in the maritime provinces? I heard somebody whisper, I heard somebody say it, trench. And that's pretty common everywhere. That is probably the most common installation method. What would be another installation method that might happen occasionally here? It happens occasionally anywhere. Jacked is a special installation, different design methodology than we could use with indirect design. The other method that we see used pretty often is positive projection embankment. Anybody know what that means? That's a big old giant word, but anybody know what that means? Basically, you're laying a pipe in an existing on the existing ground, and you're going to build the fill around it. So you're not digging a trench. You're actually going to build fill around the pipe. All right. So those are the two most common installation methods. Which one of those you think would place the most load on the pipe between trench or positive projection embankment? Which one would put more load on the pipe? I heard positive projection, right? Now, so positive projection, if it puts more load on the pipe, why is that the case? Why would trench place less load on the pipe than a positive projection? Excuse me? Confinement is part of it. What else? The bigger part of it is there's frictional forces between the in situ trench walls and the soil you're putting in. So those in situ walls, there's friction built up between the wall of the existing trench and the material you're trying to put in to backfill the pipe. So there's frictional force there helping hold some of the load off the pipe. So it's less load from the trench, more load from positive projection. That's really the key here that we want to know. And I'll explain why that's an important concept in a few minutes. Selection of bedding. We allow 4 standard bedding types, wide range of soil materials and compaction requirements in those 4 types of installation. Type 1 would be your highest quality, and we'll talk about the materials and the compaction in a minute. But in general, highest quality materials, granular type materials, high compaction. And then our Type 4 allows use pretty much of any material you want to use. We don't really care how you compact it, for the pipe at least. For the pipe design, we don't care how you do it. Now, what do you think would be different about Type 1 versus Type 4 as far as the soil-pipe interaction and the structure thereof? Type 1 is what? Type 1 is harder to compact. 4 requires no compaction, basically. 1 requires the most compaction, 95%. The big difference here is we need to have an assumption in our design of what typical bedding you're going to use, what your standards say, because the Type 1, if you have good materials, good compaction in the right place, we'll talk about it in a minute, that soil is going to provide about 40 to 60% of the structural carrying capabilities of the system itself. So it's going to carry a lot of the load. It's going to help the pipe carry load, okay? On Type 4, we do not count on that soil to carry any load. Basically, the pipe is going to carry 95% or so of the load on the system there. So we don't count on the soil in a Type 4 to carry any load, all right? So that's the big difference, and we'll talk more in detail here a little bit. A couple things, though, that are important to note, and we'll hammer on this a little bit because as I was preparing to come up to do the talk, I always like to kind of see what's going on with standards and specifications and see if I see anything that would concern me or that might be different from the standard installations that we just talked about in general. This is a picture of the standard installation, trench installation. And one thing that I saw is good stone envelope, and we'll talk about these in detail in a minute, but good stone envelope around the pipe. The thing that concerned me, though, was 95% compaction. It didn't say anything about no compaction underneath the pipe. That's important. We do not want that material compacted. There are some other constraints on that material right underneath the pipe, the bedding material, and that I think we need to understand, and we'll talk about that on the next slide, I think. A little more detail. You have in front of you also, the ones that got handouts, standard installations. And this brochure, 7 or 8, 10-page brochure, really goes through in detail the standard installation. We're talking about the standard bedding types. It has this very same picture in it, another slide or two here when we're talking about the materials requirements, the compaction requirements in the various locations. But you can see in the installation types 1 through 4, we talk about bedding thickness, and we set a standard for that. We set a standard for the material that goes in the haunch and outer bedding and compaction efforts that was required, and what's in the lower side. In your case, lower side would be, if we flip back up a slide, I don't think lower side is much of a problem for you guys, because lower side is more if we're worried about the in situ soils and make sure they're as strong as what we're putting in the trench. Here, most of the time, you're in a rock trench, I think. Here locally, you may not always be that way, but we won't talk too much about lower side today, more about the haunch areas and the bedding material. But you can see the material types are very well defined. The compaction is very well defined. This sort of ties the category 1 through 4 soils to USGS or USCS type ASTM soils, ASHTO, so you can take this information and compare it to your standards and your standard drawings and kind of get a pretty good, usually can pretty quickly determine which one of these category soils you are that you're using or requiring. As I said, another warning besides not using, not compacting underneath the pipe. We also really don't want to see crushed stone right underneath the pipe. We had way back when we first did our designs on all of our standard installations, that note was in there then. There was a warning then. It says, hey, don't use crushed rock right underneath the bottom of the pipe. We now have seen that maybe that hadn't been picked up on as folks look through our brochure. So we are actually going to add a note to all of our standard installation stuff about that very item. Crushed rock underneath the pipe. If you use it, you certainly don't need to classify that as a type or a Class 1 installation or Type 1 design. And anybody got any reason why that is? There's a caution about that. Anybody got an idea why that would be the case? Point loading. It makes it very hard. You get it very hard to hear. A lot of times you're working a rock bottom trench and then you're putting crushed stone on top of it of 6 inches. It creates a very hard surface for the pipe to set on. So you're creating some stress in the bottom of the pipe. Okay, so we just wanted to note that as we look through the maritime provinces, all the standards are about the same, very similar. There's a few little odds and ends differences, but they all use a Type 1 gravel that I saw. That Type 1 gravel usually has 6 inches of bedding or more, which is okay. They usually have 300 millimeters of cover, which I think is about a foot, if my math is right, correct? Right at a foot. For our standard design, if you look back, if you remember back a few slides, our standard design, we only care what you do up the spring line. That's what we're counting on for support in our design. What you do above the middle of the pipe or the spring line really has nothing to do with our design of our pipe. Now, we understand the materials above our spring line need to be done properly. You're trying to protect your road surface and those kind of things, or sidewalks or building or whatever, so it is important to do a good job there. It would not be necessary for design to put a full stone envelope around our product, but if you are in a shot rock, like I've seen some pictures, you guys, and I've actually seen a few job sites, you got a lot of shot rock where you're taking rock and out of the trench, and you put that back in. Obviously, we don't want you putting big boulders or even dropping big rocks on top of the pipe. That could damage the pipe. So that stone is a good protection layer. So I don't have a problem with the 1 foot of stone. It just doesn't make any difference for our design as far as what we're doing there and how we carry load. But it is a nice protection. The other thing is we talked about the granular underneath the pipe already. We don't use any Type 1 for sure. Also, it pretty much says that Type 1 stone around the pipe needs to be 95% compaction. I'm a little concerned about that because with only a foot of cover over the pipe and you put a big old sheep's foot roller, a big old steel wheel vibratory roller of some type within a foot of the top of our pipe and you hammer on it, if you hammer on it hard enough, you can damage the pipe. And so I would caution there. That's a little scary to me. I would much prefer to say once you get to the top of the pipe, the next compaction effort shouldn't be within 2 foot of the top of the pipe with heavy equipment. If you don't want to do that, I would much prefer to have smaller equipment doing the compaction. All right? I'm going to stop there just for a minute because there's got to be a question. And I see people smiling at me and looking at me like, what did he just say? Any comment about that? Any question, concern, anything I missed? Well, I'll say this. If you create a very hard surface underneath the pipe, you are putting stress in the pipe. That in itself puts some stress in the bottom of the pipe. So that's maybe enough to could cause some very small cracking in the pipe. Certainly, though, when you do that, a very hard surface under the pipe, backfill above it, and let's say you only have a foot of fill over the top of the pipe and you start compacting with a medium-sized compactor, that again is now stressing the bottom of the pipe even more and the top of the pipe. You very possibly see cracks in the crown and the invert of the pipe. Now, will they be big enough to be a true structural problem? We'll talk more about that at 1 o'clock today as we start talking about post-installation and evaluation. But you could see cracks, and anytime we see cracks, whether it's truly a structural issue or not, is a problem because the inspector sees, he says, oh my gosh, we got a crack in the pipe, and there's a fire drill to go through. Almost every time there's a fire drill to go through to evaluate that process. We're hoping our presentation this afternoon will help answer those questions, but that's the kind of things that can happen. The way to keep it from happening would be a soft material underneath the pipe, either non-compacted crushed stone, maybe be okay as long as it's not compacted, and making sure that when we get above the top of the pipe, we don't get within 2 foot with big compactors. We would use, jumping jacks, vibratory plate compactors, those kind of things to compact that material above the top of the pipe till we get some distance there. Yes, Ronald. My intent is for sure not to compact it. I think that's critical. Now, the warnings say don't use it at all. But if you insisted on using it, I certainly think finer is better. Smaller granular material with more fines in it would be better. Type 1 doesn't look to have it looks to have some fines, but it has some larger material too. So if you had a finer material, that would be good. Sand would be good. Or if you don't want to change the material type because of other design reasons you might be thinking about, at least don't compact it. That would be a good first step, is don't compact that material. Clear stone is probably, as far as less stress, is probably better. When you say clear, I think you mean no fines. A single graded stone, a smaller stone is usually what I think about, like a 1/4 inch, 1/2 inch kind of stuff. That's probably better because I'll use a very non-technical term. It's more fluffy. Okay? Now, the problem with clear stone is water can move in and out of that pretty easily. So if you use a clear stone in the bottom, under the bedding, and then you use your type 1 material above the bedding, then you could have some of that fine material from the material you're compacting on the haunch, which is a very important process. You could have some of that good type 1 material leaking down into the clear stone, if you want to call it that. So you could lose support on the haunch, which would, again, could possibly create cracks and other issues you don't want to see. So it could be done, but you'd have to put like a geotextile between the two unlike materials. Okay? So, but that is a possible thing to do. Just got to be careful with that movement of material between it. Any other question? All right. That's good. I'm about halfway. That's excellent. I got 48 slides. I'm on 25. I might make it. We'll see. All right. I'm sorry. Yes. No, I think if you use the same material, which we're talking about your type 1 granular, if you only have 6 or 7 inches of that material there, even though you don't compact it, it's compacted. It's very dense material, okay? I don't know that I believe any material self-compacting, but I do believe that if you take that type 1 material and you dump it out of a loader bucket or a track hoe, it's going to, just in itself, just placing it is going to be pretty dense. And it's not going to settle enough to cause any other problems. It would be very difficult to also only, and we'll show a picture in a minute, it'd also be very difficult not to compact right underneath the pipe and to compact the rest of the bedding. That's kind of hard to do too because you got to know where the pipe's going to be. And I would say put 6 or 8 inches of stone down and just don't compact it. Put your pipe in and then do your compaction above that. I don't think you'll have settlement problems, and I think you'll have a lot less stress in the bottom of the pipe. Okay? Good question, though. Thank you. All right. Now, let's work some examples. We'll go through these pretty quick. These are design examples. We got off there a little bit on installation and bedding types. Now, the reason that's important, though, if you don't, as far as selecting a bedding type, those bedding types are used to get a bedding factor. And that bedding factor is what takes us basically from a field load that we expect to the load we need to do the test for. So if we pick the type of bedding incorrectly or assume the wrong bedding and something else is done in the field, our design could be incorrect. Okay? So if you have, in our opinion, I didn't on the slide for this, if you do not change anything you're doing now, if nobody changes their specs or standards, if that doesn't happen, and it could happen, I guess it's okay. If that doesn't happen, they don't need to use it. You don't need, if you're designing, to use a Type 1, even though intuitively you would think that's the best installation. You got stone everywhere. You don't need to use a Type 1 bedding. You need to use a Type 2 or 3 bedding in your designs that we're going to look at in a few minutes. And it makes a lot of difference to do that. You could take you from a Class 2 to a Class 3 or Class 3 to Class 4. You could jump up in strength class requirement needed if you don't select the right bedding type. So it's important to do that. That's the reason we spend a little time on it there, even though we got off a little bit there on some other things. But it's important to pick the right bedding or assume the right bedding type that's going to be done in the field. Now, all right, for those, one of the tools we talked about as far as doing indirect design is field height tables. These are the quickest, easiest ones to use. So we use these today for sake of time. We do, as we already mentioned, the hand calculation, the blue book would be a nice place to start to learn more about this topic. But the field height table is down and dirty that I can teach you in a few minutes. Pipe Pack 3B is our software package again that you can also use. And we'll talk about when you would want to use Pipe Pack and not the field height table probably. All right, so field height table. Our first example, 36-inch ID pipe, field height of 10 foot, soil unit weight of 120 pounds per cubic foot. We want to look at a Type 1 and Type 4 bedding installation and determine what class of pipe we need to call out for in our plans. Okay? Pretty simple. I got my field height tables. Who's got the field height tables? Everybody got a field height table. Hold them up. If you got them, follow along with me now. If you don't have them, come see me later and I'll make sure you get one. But if you got them sitting around, you might as well use it. We might as well play with it for a few minutes. 36-inch ID. We'll look at a Type 1 installation, which I'll give you the page number if you can't find it. So we're looking for Type 1. It's right at the top there. You're looking for Type 1 bedding, so we got that figured out. 36-inch pipe at 10 foot of field. That would be on page 4. So somebody give me the D load for a 36 at 10 foot. What I hear? 725. All right. We even color-coded this very nicely for you. So if that's a 725 D load, that means it's a Class 1 pipe. All right? You'd probably get a Class 3, most likely, because that's what our standard is. So only required to have a Class 1, so now you design that particular pipe. Now let's look what happens. What do you think is going to happen when we go to a Type 4 bedding? Same field height, same pipe. What's going to happen? What's going to happen to the D load? It's going to increase. Why is it going to increase? We got less support from that material. In fact, we're not counting any support from that material. So now go to Type 4 bedding, and I skipped it. Looks like that's on about page 13. So 36 and 10 is what? I hear 1550 somewhere. And so what class of pipe would that be? Be a Class 4. That's how fast it is. That's pretty fast, down and dirty and simple. All right? So that's how the field height table works. Now, I'll give you some cautions in a few minutes about that. But please understand, behind the scenes now, even though it's really simple and really fast, these steps had to be done. These steps were done. They were done with the Pipe Pack software package to get you these numbers, okay? So all this work has been done for you, so you don't have to sweat over it, okay? So it makes this a little faster to use and easier to use. We've already got the answers. Now let's look at a real project here in the Maritime province here. 48-inch RCP, field height 12 foot, trench installation. We want to determine the class of pipe required here. Now remember, the design standards for the Maritime is what? full stone type 1 envelope, right? 95% standard. But what we say about that? Don't use type 1. I really don't think you should use type 1 bedding. So we already use a type 2 or 3. So let's look at type 2 and 3 just to see what the answers give us. So we're using our fill height table again. We're looking for 48, 12 foot of fill, and we're trying to determine class of pipe. And we're going to use 2 and 3. So let's look at type 2 bedding first. Pretty fast. Type 2 bedding. I am a 48 and I'm at 10 foot. No, 48 and 12 foot. What's the answer? 1050, which would be what class of pipe? Class 3. Perfect. All right, now let's look at type 3 bedding right quick. Type 3, same conditions. 48 and 12. 1300. Look where that is, though. Look on your little table there on your color chart. Where's that at? That's getting scarily close to a class 4, okay? The color changes 1 more foot. If it had been 13 foot, you'd have to use a class 4, okay, if you have a type 3 bedding. So, depending on what type of bedding you think you have, there's your load. So it could be class 3, class 4 pipe possibly there. All right, let's make sure we all got the concept here about installation and proper installation. We'll flip through these pretty quick. I think I got about 20 more slides, and I got about 15 more minutes done. There we go. See, I got to go fast. We've touched on this. We've already seen this drawing. This is your standard installation drawing for embankment or trench. You'll also see that same drawing in your installation brochure that you have to learn more about the terminology, but we'll skip on through that. We've talked about soil strength. Now, we've talked a lot about crushed stone and rock beddings and things like that. I understand there are times when you don't have that type of material. You may have more clay materials in some parts of the maritime provinces. So we're not always talking about the same thing. But your bedding materials, it is important to understand that the backfill around the pipe, that backfill up to the haunch of the pipe and under the haunch, those are the columns of material that are helping us carry the load. Type 1, we need those columns to be very strong. Type 4, we don't care what those columns are. They don't have to be very strong because we're counting the pipe. So from a soil standpoint, in those column areas under the haunch, organic clays, organic silts, peats, those kind of things, we don't really like to see that because it's very hard to get compaction. You got to have they just don't stick together, for lack of a better terminology. You have low plasticity, they don't stick together. As you move down this table here, lean clay, sandy lean clay, silty gravel, well-graded gravel, all the way down to crushed rock. Every time you move down a slot, those soils continue to get stronger and stronger. So if you compact them all the same density, even if they were all compacted the same density, the crushed rock is going to give you more support than a sandy lean clay, okay? So we take those into account into our designs, and so I think that's important for us to understand. Again, the caution about hardness underneath the bottom of the pipe, no compaction. Be careful with crushed rock. For sure, don't compact it. Trench OD, I think that's pretty simple. You can look at all the national standards in Canada and the United States. They all may be a little bit different. The maritime provinces are all a tiny bit different. Most important thing about trench width is you have enough room to get the pipe in and safely compact around the pipe. We need to compact that material, especially if you're using anything but a type 4 installation. You've got to be able to compact that material. So the equipment you're going to use to compact around the pipe, up to the spring line of the pipe, has to be able to fit beside the pipe and the edge of the trench wall. Foot and a half, a little over a foot, depending on what kind of material you're using. I think most of the drawings I saw, and if you remember the details, a little over a foot. 400 millimeters is minimum, I think. And then after you get up larger size, even more than that. So I think we're okay there most of the time. What's wrong with this drawing? What's wrong with that trench? It's very narrow. You can see there's only maybe, I'm guessing at the distance there, maybe 6 inches between the edge of the pipe and the edge of the trench. Would be almost impossible to compact any kind of material underneath the haunch there. So you got to have that area there to work with. Foundation, probably if you look at everything in a big picture, I think the foundation is one of the most important areas to be concerned about. Here, in what I've seen in this local area here, I don't think you have much trouble with foundation. You're on solid rock. It can't get no better than that as far as being strong and hard, but that does create a problem. Very, very hard foundation, and not doing the right thing between the top of that foundation and the bottom of your pipe is going to be, like we said, a lot of stress on the bottom of the pipe. So the other problem with hard rock bottom trenches that you have here locally is you get high rock. Those high rock, if they're not shot out, everything. I know it's never going to be shot out perfectly level. We understand that, but you got to get enough cushion between the high rock and the bottom of the pipe to not stress the pipe. A good 6 inches from the worst case is the way to do it. Good bedding, no settlement. But if you're in areas that have clay material or different materials than what you have here, shot rock, there are other issues as far as being stable on the bottom. We want that bottom to be stable. We want it to be stiff. Hard rock, obviously, is very stiff. But if you get a clay-type bottom, what I call a dirt trench, that material at the foundation surface has to be stiff enough for somebody about my size, a couple hundred pounds, to walk down that trench and not mar up. That's a very non-technical way to check the foundation. You can check the compaction of it if you want to do that with neutral gauge and other things like you would in any other area, or you can do standard penetration blows or those kind of things. But pretty simple. If a big old fellow like me can walk around and not make an imprint in the soil, it's pretty hard and pretty firm. We want it firm. If you don't have a good firm foundation, if you don't fix it, it's never going to get any better. Putting rock on top of it, on top of that bad foundation, and then putting a pipe on top, that's not going to fix the foundation. You got to fix the foundation if it's soft. You got to repair it. You got to condition that foundation. Usually shot rock or a crushed stone, it's to some depth, will usually fix those soft areas. But you need to fix it if it's soft. Yes, sir. Yes, sir. I wouldn't have as much concern because usually that clay underneath the soil is going to be a little softer than if you were here and had a hard rock bottom. I still would not compact the stone underneath the pipe. I still would not compact it. Okay. We've talked about all this. We want the bedding to be a cushion for the pipe, reduce stress on the bottom. It has to be set on line and grade. This is when your line and grade is established. You put that bedding material down. If that bedding material is up and down and you try to put a pipe on that, it is not going to home together very well with the joints. So the bedding has to be consistent, has to be on grade if you want the pipe to home together properly. And again, most importantly, cushion it from the bottom. We've talked about the stone and the compaction of the pipe quite a bit. I think we've covered that well. Minimum thickness, the standards usually say 3 inches in soil and 6 inches in a rock bottom. I would say 6 inches all the time, and I would be very wary of high rock. I'd make sure I had 6 inches over the highest rock if I could possibly get that. Haunch requirements, again, that's sort of the columns that help hold up the pipe. You've got to have enough room outside the edge of that pipe to compact vertically so you get compaction underneath the haunch. You cannot get a compactor right underneath the very belly of that pipe. It's impossible. But if you can get a compactor close to that, it will, especially with your crushed stone, your good type crushed stone, you'll have some good lateral compaction there, and we'll get good support, which is very important. Putting it in layers, doing your compaction. Again, I don't think there's any such thing as self-compacting stone. I think you still have to consolidate even your type 1 materials, put them in lifts, and get good compaction on that haunch area. Our overfill, this particular thing, our backfill, we consider backfill starting at the spring line, all right? Because that's really where our design stops as far as we're concerned and all the support we need. We understand the overfill area, the backfill area is important to you because you're trying to protect your structure above it and those kind of things. It needs to be whatever compaction you want. It needs to be whatever material you want. We don't care with the only exception being we don't care. We do care if you tear the top of the pipe up. And you don't want to do that either. So using large compaction equipment too close to the top of the pipe can be a problem. So we would ask you to please use caution there. Maybe put it for you guys that work for municipalities and or consultants, put a cautionary note in your standards and details would be very helpful. Now, we'll look at this afternoon, if you remember that first little, or our last example, our 48-inch pipe example with 12 foot of fill. We will look at that this afternoon, and we'll evaluate what happened to that product in the field. And because we have some issues we want to address with you that they found in the post-installation inspection. If you have any other questions, you can come by the booth, or have I got any time at all? Y'all got a minute or two. Any questions? Yes, sir, in the back. Yes. Yes. Gotcha. Gotcha. Yes, sir. Mm-hmm. You know, we chit-chatted about this some as we were preparing for this, because that's a typical question that always concerns folks. I think no matter what material you use, whether it be concrete pipe or any other pipe, so I think this relates to all products. I think when you move that trench box, if you lose your support underneath that haunch of that pipe, you lost support. I mean, you could lose support there. If you notice in the picture that of the trench that was too narrow, it really was too narrow. One of the things they'd done, they benched that trench, where that trench box did not go much below the haunch or the midpoint of the pipe. So in that case, you would not be damaging it now. But I also understand that can also be, there are rules of how far you can be above the top of the trench bottom, OSHA rules. I call it OSHA rules. I don't know what it's called here. What's it called here? I'll call it safety rules for lack of better terminology. So that could be a possible answer, but you got to make sure, first and foremost, meet your safety rules. I got you. Mm-hmm. Gotcha. I got you. Yeah. I got you. Exterior wrap. Yeah. Mm-hmm. Well, you know, if you have a bell or not a bell, let's look at it both. If you have a bell, you should be cleaning out from under that bell anyway. We do not want the pipe resting on the bell, because then you have stress on the bell when you backfill it. Okay, so that's one issue. As you get up to 36 inch, your pipe gets probably straight wall anyway, right? So 36 inches straight wall, you have no bell to kick out, but I understand you've got to kick out to get your material around it. I do not think this is my personal opinion. You know, I don't have the research to back it up. You know, as long as you don't get crazy with that kick out, as long as you just only kick out enough to get your wrap around it, by the time you get your wrap around it and then you still work around that pipe to come up the rest of your fill, I'm fairly confident that that's going to fill in and not overstress that pipe, because your pipe is still supported for 95% of the length. You're only talking about a few inches. How many inches? 2 feet. I still, it's questionable, but I don't think there's a huge problem there, because I think by the time you come up, because I assume you're stopping fairly early in your backfill process to put that wrap around it, right? I got you. So there's really no backfill around the pipe at that point. You've got the bedding in, right? I think by the time you put the backfill and haunch, I think that area is going to fill in enough and get enough support that you're probably not going to be a bad problem. That's just my... Mm-hmm. You know, even if you have... Mhm. Yes. Yep. I don't have a problem with clear stone and it being uncompacted. The only issue I think you have with clear stone is you might have soil material trying to move into that clear stone void, and you could lose some support that way. As long as you protect that, I don't have a problem. You may not have that problem here. I'm not saying you do have that problem. It's just something as an engineer or even an installer, if you're concerned you might have fine material moving into there, that's not going to be good for you. You don't want that fine material moving into that clear stone area because you'll lose support. Outside of that, it will give, and you'll lose support on the pipe at some point, or you'll lose support from above because it will actually find its way to the surface possibly. That's my only concern about clear stone. From a structural standpoint, I have no big problem with clear stone. I have no big problem calling it self-compacting. I think that's okay. You're inside the trench box. I understand that. Hard to really get equipment in there. I certainly don't think that's a Type 1 installation, though. If you're not compacting that material... Okay. All right. I misunderstood. I thought we were talking about things. As long as you're compacting... But again, if you're using stone underneath the pipe, clear stone, Type 1, whatever you want to call it, I don't think you should call that a Type 1 installation design. It should be a 2 or a 3 because I think we're having some stress there. I do not think underneath the pipe should be compacted. No, sir. I think when you add the rest of your material around in the haunch, it's going to compact to some degree when you put it in, to when you just place it. And when you do the rest of your compaction, you're going to get a reasonable support there for our pipe, and the backfill above it, I think, will be okay. Yes, sir. It's possible because if you go from let's say, we just saw it. If we used a Type 2 installation, bedding type, versus a Type 3, we almost got to a Type 1. We were right on the edge of a Type 4. And now, let me explain something. The reason I would be a little bit concerned about that, I'm out of time on it. On the fill height table, this is 120 pounds per cubic foot of soil backfill. That's how the weight is calculated. I'm guessing your backfill here weighs more than 120 pounds per cubic foot. I'm guessing 135-ish, okay? So that makes this, now this is also, the other thing about this, it is also based on positive projection embankment. So we're not considering this to be in a trench installation. So this is most conservative approach. I ran a few pipe pack designs just to see what would happen. The pipe pack design using 135 pounds per cubic foot of fill in a trench gives you about the same loads on here. You designers and engineers, you might want to run your own calculations. So I still think this is pretty close, but when I got up there, when I saw that Type 3 bedding, and I almost got to a Type 4 pipe, or Class 4 strength pipe, I might think about going Class 4 or get my pipe pack computer program out and really running it, just to check it. And the pipe pack program will let you do a lot of things. This is tractor trailer load, 120 pounds per cubic foot, embankment fill. That's your little fine print on here. So you may run across condition when you have an installation that this cannot be used for. Pipe pack will give you that flexibility. I got to go, Donna. Yeah.
I think there's probably still quite a few questions to be asked, and a lot of people in this room that still have wants further information. Al's going to his booth right now. We have the other session starting here for the EcoFlow. The EcoFlow on-site sewage treatment system that starts right now. Al's going to his booth, so the pipe guys that want to discuss things with him, feel free to leave. But the other thing is we are having the other session at 1 o'clock. If we get the room full, close to 12.